Hello everyone, so welcome to my YouTube channel. So welcome to the CA Foundation paper 307 code. So today is a day 9, and first of all I am really very sorry guys. Almost it is a long gap, and then again I'm going to start this day 1, day 2, day 3, day 4, day 5, day 6, day 7 till day 8 we had completed. Now I'm going to start with the day 9, and this time it will be not going to like long gap and all. And very important thing is, with that I am uploading the CA Foundation quantity aptitude whole syllabus, maths, statistics and logical reasoning in the same channel. So what you have to do is go to the playlist, and in that the third playlist you will see the CA Foundation Jan 2026, June 2026, September 2026. So you can do from there also. Okay, and let's start. Okay, so fine. If the variables x and z, okay, so this is the chapter we are doing today, is the measures of central tendency. Okay, so if the variables x and z, so we have a variable x and z are so related that z equals ax plus b for each where a and b are constant. So what we get to know from here? We get to know that we have x and z as a variable, and a and b are the constant. A and b are the constant means a and b is some number. A and b are some numbers. Okay. So they are given z equals ax plus b. So mostly we will focus on the variable. So what are the variables? Z and x are the variable. So what they had given? They had given related z equals ax plus b. Then z bar equals ax bar plus b is, like, whether it is true, false, both, none. So understand one thing, z equals ax plus b. So z bar equals ax bar plus b. Obviously a and b, to forget about this because a and b are constant. Just we'll see the variables. Z is in the normal form, the x is also in the normal form. Now we have a z bar means the mean of z. So here we have a mean of x, means it is changing, yes, it is changing according to that this equation, and the z value and x value both is changing, like related to each other. So it is true. Next, this is very important, the question number 2, guys. They keep on asking this type of question. So this type of question they will ask only for the mean, or you can say arithmetic mean or average. They asked if each item is reduced by 15, then arithmetic mean. So very important thing, guys, you have to understand one thing is, for the arithmetic mean, if each item is reduced, then arithmetic mean will also reduced. If each item is increased, then arithmetic mean will also increased. If each item will multiply, then arithmetic mean will also multiply, and if each item will divide, then arithmetic mean will also divide. Okay, because it is a mean, it totally depends upon what the item, how the item is changing. So suppose they will say if each item is reduced by 15, so arithmetic mean will also reduce by 15. If they will say if each item is increased by 15, then arithmetic mean will also increase by 15. If they will say if each item is multiplied by 3, so arithmetic mean will also multiply by 3. If each item will get divided by 10, so arithmetic mean will also get divided by 10. So whatever the changes happen in the item, like the observation, the same changes will happen in the arithmetic mean. So here they said if each item is reduced by 15, the arithmetic mean is also reduced by 15. Next, the average of a series. Average means what? Yes, arithmetic mean. So the average of a series of overlapping average, guys, very simple thing, overlapping average. Overlapping means like this. See, this is overlapping, right? This is overlapping, right? This is overlapping. This is overlapping. This is overlapping. This is overlapping. Okay. So each of which is based on certain number of items within a series is. Now see, first thing is simple average. Simple average we know. We will add all the observation divided by total number of observation is a simple average. Weighted average. Weighted average where we will, yes, introduce the weight also. And next is moving average. So this is a moving average. Overlapping average means what? Moving average. You can see overlapping means what is happening. You can see I started from here, but overlapping, I reached here. So overlapping means what? Moving average. Next, the mean of 20 items of a data is 5. So what is the mean? The mean of 20 items of a data is 5. If each item is multiplied by 3, then the new mean will be. Just now I explained you, right? How the item will change, the mean will change according to that. Same. Okay, so each item is multiplied by 3. So what will happen? Yes, the mean will also multiply by 3. So each item is multiplied by 3. The mean will also multiply by 3. So what is the mean? Mean is 5. So what will happen? It will multiply by 3. So 5 3 the 15. Next, the algebraic sum of deviation of a set of values from their arithmetic mean. Easy guys. See, algebraic sum of deviation. Deviation where we have studied? Yes, in the measures of dispersion chapter. In the measures of dispersion chapter we have studied range deviation, range, then all the deviation, quartile deviation, mean deviation, standard deviation. So we had studied the deviation there. So what will happen? In arithmetic mean we have not seen any type of deviation. Deviation is in the measures of dispersion, and in measures of dispersion we have a different deviation, right? So very important thing is understand that there is standard deviation, mean deviation is also there, quartile deviation, but very important thing, the algebraic sum of the deviation of set of values from arithmetic mean. If I will take the algebraic sum of the deviation, if I will take from arithmetic mean, it is equals to 0. Okay, see, sum of deviation of set of value from arithmetic mean. Okay, they are talking about arithmetic mean, they are not talking about the mean deviation. Okay, deviation from the arithmetic mean. Okay, it's not like a deviation from quartile deviation, deviation from mean deviation, deviation from standard deviation. No, they are talking about the sum of deviation from arithmetic mean. So in the, like the chapter number 2, the central tendency, we had studied about mean, median, mode, geometric mean, harmonic mean. So that's why if we will take the algebraic sum of deviation, if I will take from the arithmetic mean, it will always be 0. Next is, which one of the following is not a central tendency? Central tendency we know, right? Central tendency we have arithmetic mean, median, mode, geometric mean, harmonic mean. Mean deviation we don't have, because mean deviation, standard deviation, quartile deviation, range is in, yes, measures of dispersion. Very important, 7th number guys, very important, the 7th number, because this is easy, we know how to do, we did this type of sums, but for reading the question you will get confused. Let's see. They said if total frequency of three series are 50, 60 and 90. So if anyone will read the question, first of all what the thing will come in your mind? They are talking about total frequency of 3 series are 50, 60 and 90. That means, okay, they are talking about total frequency of the series are 50, 60, 90. Means 50 is the frequency 1, 60 is the frequency 2, 90 is the frequency 3. This thing will come in your mind because they are saying total frequency of the series are 50, 60, 90. But we will read the further question and then we'll analyze it. And their means are 12, 15 and 20. So guys, we have to find the mean. We will get the mean of what? Mean of observations. We will get the mean of what? We will get the mean of observations. So for the set of observation, we will get their respective means. Right? For the For the, if you remember the combined mean, for the n1 set of observation we will get the mean x1 bar. For n2 set of observation we will get the mean x2 bar. For n3 set of observation we will get the mean x3 bar. So for the set of observation we will get its mean. So they are saying there, and their means are 12, 15 and 20. So whose means? Number of observations, set of observations mean. Whose mean? Set of observations mean. So this is not a frequency, this is a set of observations. These are the 50 is the n1, 60 is n2 and 90 is n3. These are the set of observations and their mean is x1 bar, x2 bar, x3 bar. So this is the important and tricky question. Then their mean of their composite series. As composite means, yes, combined. Composite means combined. So we have to find the combined arithmetic mean. We know the formula of combined arithmetic mean. It is given 3. So what will happen? The formula for combined arithmetic mean. Combined arithmetic mean means n1 x1 bar plus n2 x2 bar plus n3 x3 bar whole divided by, yes, n1 plus n2 plus n3. You know n1 is 50, n2 is 60, n3 is 90 and their respective mean is x1 bar 12, x2 bar 15, x3 bar 20. That's it. So you use the calculator, we will find it. So they are given the total frequency R, but we will get, and then after that they said and their means. So mean means what? We'll get the mean for the set of observation. So 50, 60, 90 are the set of observation and their means are 12, 15 and 20. Then they said then their mean of their composite series. So composite series means what? Composite means combined. So combined arithmetic mean we have to find. Okay, so n1 is 50 into x1 bar is 12. 12, 50, 12, 5 is 60. 60, 600 plus n2 into x2 bar. So n2 is 60, x2 bar is 15. 15, 6 are 90, 900. Then n3 into x3 bar. So n3 is 90 into x3 bar is 20, 1800. So you will get 3300 divided by n1 plus n2 plus n3. The n1 is 50 plus n2 is 60. 110 plus n3 is 90. So 200. 16.5. 16.5 is the answer. So this is the thing. If you will, like, you know, if you will keep on solving these many questions, easily you are going to score 80, 85 plus nearby 90 in the quantity aptitude paper 3. So keep on doing, guys. We will meet in the next video. So bye bye. Take care.